Hi, I'm Mike.
I'm Scott.
And I'm Mark.
We are your screen machine product support team, and here's another quick tip. Today we'll be going over a typical DO3 double solenoid valve that I've got in front of me here, and just some basic overviews of the different solenoid valves we use in our machines, how they operate, how they function, some troubleshooting tips, and some items like that. So in front of me, like I said, I've got a typical DO3 solenoid valve. We have multiple different kinds of these. This is a DO3, which just refers to the size of it, basically. And this is a typical track valve that we use on like our 107Ts, our 516s, 514s, machines like that. On our larger machines like the crushers, it would look very similar, but it would be a lot larger, and that's what we call a DO5 solenoid valve. So you'll find these in the engine compartment of your machine, and all they do is they control electronically. They'll usually be plugged in, and well, they will be plugged in if they're working, and they control where you're sending hydraulic flow out to certain functions of your machine. So when I say a double DO3 valve as well, that just means you've got an electronically actuated solenoid on either side here. If I say a single solenoid valve, it would just basically look like this without the section on there. So we would use a single solenoid valve for on-off functions, like turning a feeder on and off, main conveyor on and off, something like that. But anything that you have two separate directions the flow needs to go, like a track valve, one side would be forward and one side would be reversed. So you've got the double acting solenoid and not just the on-off. So a couple of basic things about these valves. Like I said, we use a few different models, but mostly across our machines they're pretty standard. You've got part number right on the valve, hydraulic schematic right on the valve for how the internals of this valve work. This would bolt up to a manifold inside of, like I said, inside of the engine compartment. This would bolt up to a manifold housing. That's what we've got these O-rings on the back. You can see that's where it actually bolts up to the manifold right there. A couple things about bolting these up if you're ever replacing them or doing any service work like that. There are four little O-rings you see back there. Make sure those are in good condition. Make sure they're there. They're not ripped, torn, or anything. You don't want that to get into your hydraulic system and cause you issues there. And whenever you are installing these valves, there is a proper torque spec for the different sizes of these. If you don't torque them enough, you can get material, or you can get fluid leakage. If you torque them too much, you can actually distort this housing, and it won't allow that spool to move back and forth like it should. So if you're ever out in the field doing anything with these and you need some information on specific torque specs for these bolts on them, just contact the product support team here and we'll give you the exact number, because it's a little different for the DO5s and the DO3s, and depending on which supplier we got them from on your machine, might change that as well. So torque specs and O-rings, if you're ever installing them, are very, very important to keep an eye on. But pretty simple here. I don't have the machine. I don't have this hooked up to machine or anything, so you can actually push on both of these ends here, as I'm doing now, and you can feel that spool moving back and forth. That tells you nothing's stuck in there. Everything's good. With the machine off, you can do that as well. But yeah, these will be plugged in. They'll also be either 24 volt or 12 volt, depending on machine. This is for one of our 24 volt machines. It says it right on there as well, right here on the coils, whether it's a 24 or 12 volt for that unit. We'll do a little bit of troubleshooting information on here as well. So let's say you're trying to track your machine. You're trying to use your remote here. You've got it in move mode. The alarm is sounding, and you're hitting right track forward. Nothing's happening. You're wondering, could it be a hydraulic problem? Could it be an electronic problem? Where do I even start? So what we would always tell you first way to start is, let's make sure that solenoid coil is actually getting power. So on all of our machines, whether it's an older style DIN plug or what I have here is a Deutsch plug that I've got hooked up to a power source right there, you can see that it's lit up pretty good. Whenever, like let's say we've got it in move mode and I'm hitting right track forward, and this is my right track forward Deutsch plug, which it would have a label on the harness as well as to which one it is, and it would be going up to your valve. It would be lit up just like that. And this shows that you're getting the proper voltage to it too. If I go ahead and turn that down, you can see that the light actually goes out. So now I'm at about 20 volts, About 22 is when that light starts coming on. So you do need to get that full 24 volts into this as well to make sure. If you're only getting 12, 14, 16, it's not going to function properly. It's a 24 volt valve. It needs 24 volts. So this is what it would look like if I was holding the right track forward. Okay, we're getting electric power. That's the first step there. That's really the first troubleshooting. We know we're getting power. We know everything with the controls are working right. The remote system's working right. All that good stuff. So the next thing, we've got it plugged in, and you'll hear when I plug this in, you can actually hear, and I bet you actually saw that move. I'll shift it to the other side here so you can actually see that shift in there. There you go. You hear that? So kind of neat. That tells you you're getting power. You can actually hear it shift. You can go hear it go back and forth. The solenoid's moving in there. It's not over torqued. It's not over tightened. We don't have a bad coil. We don't have anything else. We don't have something going on with that. We know we're getting good electric power, and we know that it's making its way to the valve while we're pressing on the remote. So that's good there. Another troubleshooting tip here is you can actually screw these off. I just used a pair of channel locks to loosen it up a little bit. It wasn't very tight, but it was a little tight. And the other thing, especially if you've got an older machine that's got some age on it, you can just screw this cap right off. That's where you can also see this plunger in here. This, I don't know if you can see in there or not, but inside of there, there's a little plunger that goes into the hole on the end of that, and that's what you're actually pushing on when you're forcing that back and forth. So we're going to take that cap off. There's another O-ring that goes right in between that cap and your coil there. And now we're just going to take the coil off. So whenever we're talking about a coil on the solenoid, you can see the innards of it a little better there. This is what we've got is the coil. No power to it. I'm going to take my screwdriver. It's not magnetized. If you do have power to it and it's not sucking that screwdriver in, then you have a bad coil on your machine. Sometimes on older units, we see that this coil has been corroded and it's kind of stuck on that shaft like that. So I'll show you how it's supposed to act when you're supplying power to it. I've got power in that coil right now. Take my screwdriver. It actually pulls it into that coil. It'll hold it like that. Pretty good force onto there. It'll actually take, if you've got a smaller screwdriver, it'll take it out of your hands pretty much. So you want to make sure that your coil's got good magnetism. This is a little better steel. You can see how much it's really pulling it out of my hand. So this coil is nice and good. We know we don't have any problems there. Just a neat troubleshooting item for you. If the coil's good, just slide it back on. Don't force it on if there's anything wrong with the shaft. Put it back on there. We're going to make sure we put all our O-rings back. Make sure there's nothing wrong with this plug connection. We use dielectric grease in all of our plug connections. These are sealed, but it just helps seal it a little more. Obviously, these machines are always in pretty dusty, dirty environments. We want to keep it sealed up as much as possible. So when you're plugging that in, use a little dielectric grease on there. Make sure it's all nice and snug in there. You don't have any physical damage that might cause this to be loose in there. Anything like that. But these are all pretty standard, like I said, across the board for our machines. This is a DO5 double acting solenoid. For our larger crushers, it'll be this is a DO3 double acting solenoid. For our larger crushers, it'll be a DO5. Or for, like I said, just your on-off functions, whether it's a screen, a main conveyor, a feeder, you would just have a single acting solenoid right there. So very simple. If all that troubleshooting checks out, if we're getting electronic power up to this, if the coil's magnetizing, all that kind of good stuff, if you can push on it and you can feel that spool move, it's not stuck or anything, then chances are things with this particular solenoid valve electronically, you're not having any issues. Then that's where we would move on to inspecting the machine a little more on the hydraulic side of things. So I think we covered pretty much everything with this valve. Your ports are labeled right on there. Everything's pretty simple. A lot of good labels on here. The voltage, your schematics, like I said, everything's right on there. And if you have any other questions while you're working on this, just give us a call.